Alright, welcome back class. We are going to continue with optimization problem. So we are going to solve application problem using derivatives. Right, so this tutorial question, you are required to design a rectangular poster that contains 300 centimeter square of printing with a 10 centimeter margin at the top and bottom, and the 5 centimeter margin at each side, right and left. So what overall dimensions will minimize the amount of paper used for the poster? Right. So first of all, we know that the poster will contain 300 centimeter square of printing, and the margin at the top and bottom will be 10 centimeter and 5 centimeter on the side. Alright, so let's draw our poster first. Right. It says here it is a rectangular poster. So, right, and contains 300 centimeter of printing. Right, let's say this will be our printing, and the area of the printing is 300 centimeters squared. And let's say the area given here will be X and Y. Right, what about the margin? The margin at top and bottom will be 10 centimeter. So this margin here is 10 centimeter, both of it, bottom and top, and margin here would be 5 centimeter on each side. Right, this would be 5 centimeter and 5 centimeter. Right, so question would like us to find the dimension of the paper. Alright, so how do we find the area of the paper? We know that the area of the printing is 300 centimeters squared. Right, so printed area equals to 300 centimeters squared, and we know how to find the printed area by multiplying with the length and width. So length equals to X and width equals to Y. From here we can factor out Y and get Y equals to 300 over X. Right. So once we get Y, let's continue with finding the area of the paper. Paper area. Right. So in order to find the area of the paper, we need the length of the paper and the height of the paper. Right. In this case, the length will be X plus 5 on both sides. That makes it 10, and Y, this will be Y plus 10 on both sides, top and bottom. So the paper area will be length, which is X plus 10, and width is Y plus 20. Right. Next step, right? Let's expand this. Let's expand this. Expanding this, we get XY plus 20X plus 10Y plus 200. The next step will be substituting Y in order to get our function of this area in one terms. Right, so we are going to substitute this Y inside here and here, right? So let's do that. So x times 300 over x is 200. Right, so x here and x here can cancel, so you get 300, right, and here we have 20x. 20x plus 10 times 300, get 3000 plus 300 plus 200, 500. Alright, so in order to get the minimum area of the paper, we need to find the critical point first, right? So area here let's denote as A, right? Function of A, the derivative would be dA dx equals to 20 minus 3000 over x squared plus 0. No need to write. Right, and in order to get the critical point occurs at the derivative equals to 0. This thing here equals to 0. Right, solving this, we are going to get equals to 20. Multiply x squared both sides, get 3000 equals to 20x squared, and 3000 divided by 20, we're going to get x squared equals to 150. So we get our x equals to square root of 150. Right, so next step is to check whether at x equals to square root 150 will gives us the maximum or the minimum value. So checking second derivative, right, we're going to continue from here. So first derivative dA dx equals to 20 minus 3000 over x squared. So second derivative, second derivatives equals to 20 becomes 0. Negative 2 bring in front, you're going to get positive 2 times 3000 over x cubed. Right, so at x equals to square root 150, gives you a positive answer. Right, so positive second derivative indicates that the graph is concave down. Right, so concave down means it has a minimum value. Right, so since we confirm already that at x equals to square root of positive square root of 150 is going to give a minimum value of a, so we can substitute x equals to square root 150 inside here to get the dimension of the paper. Right, so let's substitute x equals to square root 150. So we're going to get length will be 150 plus 10, and width will be, right, so the width we are going to get 300 over square root 150. Right, so if you press your calculator, you're going to get roughly at 12.25 for square root 150. So adding 10 to it gives you 22.25 centimeter, and this will gives you 24.5 centimeter. Right, so that's will be our dimension.